Okay, welcome back. This is B-Dog with lecture 4.2 of the structure of the atom, or the atomic structure chapter. 4.2 is the structure of the nuclear atom. And first we have to explain what static electricity is. And static electricity was first noted as a property when amber is rubbed with a piece of fur. Now, amber is petrified tree sap, and it was considered a jewel back in the day, thousands of years ago, and you could rub it against rubber. I'm sorry, against fur, and you would get, you'd get the static electricity. The same thing happens when you are uh, walking in like flip flops, and you're holding the shopping cart when you walk through Costco, and then you touch one of the shelves, and it gives you a pretty nasty shock. It's awesome. I love doing that at Costco. Uh, right. So that's the first notation of static electricity. And interestingly, the name for amber in Greek is electron, which I have always found very interesting. Okay. Now, Ben Franklin detected the same static discharge in his famous kite experiment. Anywhere else in the world aside from the United States, he is considered a great scientist before being considered a founding father of the nation. His experiments in electricity were very important for current understanding, as well as his inventions of the bifocals and the Franklin stove and the creation of the U.S. Post Office. Now, electrons were discovered by J.J. Thomson with a modified cathode ray tube, a CRT. And so here's how a cathode ray works. Electrons are shot from this this cathode right here. It's an abundance of electrons. It's called a capacitor, and it holds a bunch of electrons. And because there's an anode over here which attracts electrons, they get sucked off the cathode and fired towards the anode. But there's a hole in this anode which allows the electrons to pass through. Normally, they would wind up at this phosphorescent screen over here and create a little dot where it hits the screen. However, what Thomson was able to do was create a positive and negative. He passed the beam through an electric field with a negative side here and a positive side here, and the particles that are now known as electrons would deflect towards the positive side of the plate. And because he was able to measure the angle at which they were deflected from their original path, he was able to determine the mass of the particle. And he could tell that it was negative, but then when he was able to determine the mass, he knew that he had an actual particle involved there. So that was the discovery of the electron using the cathode ray tube. Okay? And so the electrons that were detected were influenced by a magnet or an electric field. There is nearly no mass to them. They are 1 times 10 to the negative 31st kilograms. Okay, there's a negative charge. Alright, so electrons have a negative charge, a charge of -1 for our purposes here. And now you may see common versions of the CRT at home. If you have a TV screen, those are miniature CRTs, and the lines of the CRT are manipulated by the magnetic field, allowing the electrons to hit the screen in a particular order. Now, from this, Thomson developed the plum pudding atomic model. And so that looks a little something like this. And this would be the plum pudding model, where you have a positively charged bulk of matter in which you have electrons embedded And so we knew that we had these negatively charged particles. And so his idea was that we have this, at the very least, we have a positive sphere, and all of the stuff that the sphere is made out of has a positive charge. And the individual electrons can all be extracted from that, and they would all have their negative charge. That was his idea of the plum pudding model. Now, Thomson was able to determine the mass of the electrons, which was 1 times 10 to the negative 3rd kilogram, and he knew that they were negative in general. But it took Robert Millikan's oil drop experiment to determine the quantity of charge carried by the electron. He was able to find the charge to mass ratio. And so if you have the mass and you multiply it by the charge to mass ratio, the masses will cancel and you'll get how much charge for every unit of, for every particle of the electron. Okay, then we discovered protons, and protons were first discovered by Eugene Goldstein in 1886. Okay, and they observed that there were particles traveling the opposite direction from electrons, and they were ultimately called anode rays. So if you remember up here, we had cathode rays being that Thomson studied. Okay, Goldstein studied anode rays, rays coming from the anode traveling towards the cathode, and these were found to have a positive charge. Then finally we found neutrons, and neutrons were discovered by James Chadwick in 1932. But notice it took 46 years after Goldstein discovered the protons to discover the neutrons. Okay, there was no charge, and the mass was approximately the same as a proton. So why did it take so many more years? Because neutrons are neutral, they're neutrally charged, and so the only way they could find them was by varying the mass, and was by the mass of the particle. The only way to detect them was the difference in their mass. We are going to pause right here, and we're going to end this particular video after neutrons, because the next step in the development of the atom is a bit involved and should have its own lecture associated with it. So, we will pause midway through 4.2, and this is P-Dog signing off.